So, friends, welcome to this lecture series of geomorphology, and today we are going to discuss about shoreline platform in this class. So, if you remember our last class, we are talking something about wave action, tide action and wind action, and finally, due to wave action, we have created two types of topography. One is cliff, another is called this platform. Cliff, it is a steep bedrock on the shore face, and a platform, it is around 1 degree or less than 1 degree. So, mostly this shoreline platform, it indicates the intertidal zone, and either it will be of a thin sediment cover or it will be completely of bedrock. That depends upon the degree of erosion, the ability to erode this rock by these sea waves and so. So, finally, we will today discuss about this geology and geomorphology of this shoreline platform. So, if you see this figure here, this is a cliff and this is a shoreline platform. See how wide this shoreline platform will be, and what should be this geomorphology, either it is a plain or it will be wavy or it will be sediment field or less of sediment, that will depends upon the wave action and this degree of erodibility of this cliff rock. So, the hydraulic pressure and turbulence of the breaking wave can erode easily weathered rock fracture or fractured rock or the fresh bed rock also. So, there are two types of pressure or two types of activities by the wave. One is your hydraulic pressure, another is a turbulence of breaking wave. Either of this case, there will be removal of this rock material from this cliff. And in early days, suppose for example, this is the cliff surface and this is the cliff surface, and we are increasing the sea level like this. So, the sea will be of this level, for example, if the sea is at this level. So, this area which rocks were fractured and there is fragmented. So, those rocks will easily be removed by this wave. So, these type of activities of removal of fractured rock, fractured bedrocks, that is called hydraulic blocking or wave blocking or quarrying. So, wave blocking and blocking or quarrying, it is a general term used both for river, both for glacier and for wave. So, it is for wave, it is wave blocking, or it is a glacial blocking, or it is a river blocking. So, blocking nothing, it is blocking is simply removal of fractured rock as it is from this main source or from the main rock body, this is blocking. So, now you see when we are increasing the sea level up to this, so wave is directly interacting the rocks of this region. So, that means here there will be fractured rocks will be removed back. So, this is called wave blocking or quarrying. Even though wave blocking is restricted to a narrow vertical zone, high cliffs can result if slide rock is exposed from this talus and it is at this cliff base, that is sea caps or notch may appear. For example, if you see here, once we are removing the material, suppose this due to removal of this material, here we are creating notch. So, once notch we are creating here due to the wave action, this part of this cliff will not stable. So, here this term comes again the role of mass wasting. So, that will either free fall here, that is topple, or it will simply fall, rocks will be fall from here. So, finally, if this type of erosional system occurs, that is there will be mass wasting. So, that means there will be a retreat of sea cliff towards the land mass. So, mass wasting it plays important role here to retreat the sea cliffs. So, but to make it available for this, to make it convenient for this mass wasting, this notch is playing important role. So, formation of the notch it is due to this wave action, and due to the wave action this material is removed, this part becomes gravitationally unstable and finally it falls down. So, here two photographs are shown how these notches are formed. You see, these are the notches, these are the notches, and finally due to notch, finally this pillar, if it is removed, then this part of this material will easily fall into the system. This is the result of this cliff retreat and due to this notch formation. As plucking deepens the shore zone notch or erodes rock or the sea cliff, the shore platform widens. Why? Because you see, one suppose for example, when this sea level was here, so this notch was not formed. So, this width of the platform was this much. As notch form, that means this much width is added to this. So, that is why with more and more notch, more and more deeper the notch. So, this the area if it is notched back. So, this sea platform that will widens. So, if it widens, so that means this sea level is increasing and increasing. So, if this sediments is removed from here, it will be remain here during high tide, it will move up, during low tide it will move down. So, there will be to and fro action of this eroded sediments. So, this eroded sediment either it will be here or it will move along this sea platform to the deeper level of the sea, that depends upon the strength of these waves. So, it is the surf zone and sediment from wave plucking and cliff retreat is dragged back to the back and forth across the platform to sharpen the abrasion ramp. So, this platform is called abrasion ramp. Ramp, if you see, it is a flat surface. So, this is gently dipping 1 degree or so or less than 1 degree. So, now you see whatever the sediments removed from this region, now they are lying here. Thus, a seaward slope of transportation develops on an eroding surface thinly veneered with rock debris of active transport. Now, see the grain size will decrease from this landward to seaward, and finally, this size or this width of this sea ramp or abrasion ramp, that depends upon how much sediment we are eroding here and how much we are transporting into the sea. So, if this transportation is up to 2 depth, so that means it will not come again by the wave action. So, that means in that case we are losing sediments from this abrasion ramp. Otherwise, there will be to and fro movement along this abrasion ramp, and finally, we are getting thin sediment cover on this abrasion ramp. The abrasion ramp extends seaward until the debris is either abraded to fine sediment, dissolved or settle into the water too deep to further wave movement. That means, here it is said that if it is the sediment is gone up to too deeper part of the sea and it will never come back due to this wave action, that means we are losing the sediment. Otherwise, we have sediment and gradually we are reducing the grain size by to and fro motions. This gentleman Bradley in 1958 measured the profile across modern abrasion ramps and emerged coastal terraces in California shows typically seaward gradient is about 1 degree, that we have already discussed. It is a very gentle slope and it is 1 degree or so. So, if the angle of repose is more like this, so there will be easy removal of this sediment, but as it is 1 degree or less than 1 degree. So, that means it is not easy removal of the sediment from the surface. That is why sediment passes long time on this abrasion ramp, and finally, due to this long duration of stay and frequent action of this wave by to and fro motion, their grain size reduction occurs, their sorting increases. So, that is why in a shore zone we will get highly sorted sediments as compared to this pure fluvial environment. On a tideless shore, such gradient would exert between 10 meter depth of the ordinary wave erosion and bench becomes no wider than 500 meter. So, if it is not tide, no tide is there, tideless shore, that means sediment will remain idle. it will not transport, significant transport will not occur. So, if significant transfer is not occurring towards seaward, that means our seaward platform, seaward ramp becomes narrow. But if due to tidal action the sediment is transported into the seaward, that means we are getting wide sediment ramp is there. If the tidal range is about 5 meter, it assumed as abrasion ramp with about 1 degree gradient could still be water depth about 800 meter. So, that means if we have 1 degree slope is there and tidal range about 5 meter, still we are getting an abrasion ramp of width about 800 meters. So, that means tide here plays an important role. What should be the width of an abrasion ramp? If it is tideless, that we are getting narrow zone and all the sediment will be stuck off here and there will be less sorting and thick sediment cover and this will be about 500 meters or so. But due to tide action, even if 1 degree ramp is there, that means we are getting the sediment transported up to 800 meter and finally there will be sorting and so. So, wider shore platforms cannot be developed by abrasion at a fixed sea level, although they could form during progressive submergence. It is very important here to understand. If we have idle sea level, that is fixed sea level, it that means there will be not much transport, there will be not much wave action, much wave tide action. So, that means here there this platform, this abrasion platform will not develop very finely. So, if we have to develop a wide abrasion ramp, so that means we have to either increase or decrease the sea level. That means like this we have to make the system dynamics rather than static. So, abrasion platforms can form rapidly on weak rock, that is very important. Weak rocks that create very rapidly abrasion platform. The subhorizontal shore platform up to 200 meter width was cut to 600 years across erodible mudstones on the east coast of New Zealand. This is an example is given, it is mudstone was there and mudstone is weak, mudstone is a weak rock. So, a abrasion platform of 200 meter width cut in 600 years across erodible mudstone, but had it been on granite, had it been on condylite or basalt, this 200 meter it might have taken 2 million years or so. So, due to this presence of weak rocks, this width of this abrasion ramp increases very rapidly and we will get a very wide abrasion platform. Like in east coast there is a place in Odisha and Bengal border that is called Digha. You will find this abrasion platform, wide abrasion landform. During low tide you can move up to kilometers distance and during high tide the whole system is submerged under sea. So, this is due to the Gondwana sediments, there Gondwana sediment is there. So, that means if it is weak rock, we are getting a wide abrasion platform within a less time period, but same east coast where there is condylite is exposed, where the cyanocite is exposed, we will not get a abrasion platform more than 50 meters or so, but in that Digha we are getting a kilometers or more than kilometers. So, this is due to this rock characteristics. Then another type of weathering is called water level weathering. This term was given by Wentworth 1938. It seems to be the dominant process that widens and flattens shore platform on non-carbonate rocks, that is called water level weathering. It seems to be the dominant process that widens and flattens shore platform on non-carbonate rock, because carbonate rocks they are more prone to chemical weathering than mechanical weathering. But this water level weathering due to this action of water. So, this is mostly at non-carbonate rocks. There are pools in the intertidal zone, we are getting some pools and separated by a ridge. Similarly, there are pools are separated by a ridge. So, here you are getting some salt spray, that means this photograph you see there will be salt depositing on the surface of these rocks due to evaporation of water. So, if you remember when we are talking about weathering and erosion, so in that case we are talking about a term that is called taphony, TAPHONI, taphony. This taphony is the characteristics feature of physical weathering by this salt action. So, due to salt overgrowth or that precipitation of salt. Similarly, if you see here the intertidal pools, you see these are the intertidal pools and salt sprays on abrasion ramp or in the wave plugged notches promote weathering in this zone just above this permanent saturation. This is the zone of permanent saturation. If this is open sea this side, open sea this side. So, here in the intertidal zone, that means during high tide we can get water this level or low tide of this level. Similarly, during high tide this total system will be submerged. So, in that case what we will get generally the intertidal pools and salt sprays. So, the spray zones just above normal high tides is a zone of specially active chemical weathering. See here normal high tide, beyond this normal high tide, because in the during tide the salt will dissolve and remove, but once the area remains above the high tide. So, there will be permanent salt accumulation zone, and salt accumulated on the surface of this rock, they will promote chemical weathering. Similarly, this terminology we have already discussed in our weathering class, that is taphony or honeycomb weathering, form rapidly in the zone of spray during and drying. So, these are these boxwork like structures, honeycomb structures. These are the characteristics feature of salt erosion or salt spray erosion. Then some salient features about this: lower and higher zones which remain either wet or dry for long intervals are less affected here. So, that means the intermediate zones are more affected. The lower zones which are under permanent water cover, that will be less affected. The higher zones which are above this permanently above the water zones, they remain unaffected or relatively more stable. However, the intertidal zones, these zones are mostly affected by this type of weathering activity. Wave erosion during high tides carries off the weather debris. So, whatever the debris we are creating during weathering, during high tide the whole product will move back to the sea. On exposed platform, all stages can be seen through initial ponding in joining these bounded basins or the joint bounded basins to coalescence of flat floor separated by this serrate of ridges. So, bedding planes and joints are frequently etched at higher reliefs. Yeah. So, that means these areas on exposed platform, all stages can be seen. So, though whatever we are talking about either in the permanent zone, permanent dry zone or permanent wet zone or intermediate zone, all those platforms, all those activities can be shown in wherever there is a cliff section, there is a vast erosional platform is there, in these areas that can be well studied here. Bedding planes and joint are frequently etched in high relief. Why? Because these are the weak planes, joints, bedding planes, these are the weak planes. Then shore platforms are developed by water level weathering at various heights relative to tide level, depending upon the structural factors such as permeability, fractures and also on wave energy, tidal range and climate. So, these are these parameters, that permeability. If the rock is more permeable, so that means it will allow the rock pass through it. So, more permeable rock will weather fast as compared to non or less permeable rock, because free movement of water will be there. Then similarly, fractures that provides the avenue to pass through this rock inside. Then wave energy, how energetic the wave is. If it is wave is highly energetic, that will forcefully enter into the rock pores. Then tidal range, if its tidal range is low or tidal range is high, and the climate, if it is wet climate, it is dry climate. So, these are the parameters, tidal range, climate, wave energy, then fracture, permeability, that depends the shore platform, how the shore platform will develop, what should be the nature of this shore platform, that depends on all these factors and the rock types also. Water level weathering puts the finishing touch on surface prepared by wave abrasion and flocking, especially volcanic rocks such as weakly indurated pyroclastic sediments. This is very important to understand here. This water level weathering, that means water remains at the particular level, either it is increasing slowly or decreasing slowly. So, this water level weathering, it is gives the finishing touch, that means it polishes the rocks. So, during hydraulic blocking, during mass wasting, we are creating a rough surface, and that rough surface is gradually polished by this type of hydraulic action, where it is water level weathering, and mostly it is affected by volcanic rocks, because we know in our weathering classes these volcanic rocks, they form in a different kind of temperature and pressure conditions. Once they are interacting with this level, that is this geomorphic agents, surface geomorphic agents, they becomes more unstable as compared to the sedimentary rocks which form at this surface temperature and pressure conditions. So, that is why the volcanic rocks such as weakly indurated pyroclastic sediments, they are more affected. So, pyroclastic sediment where we will get? We will get at the volcanoes. So, in oceanic surface we will get number of volcanoes, like if you go to this Pacific, chain of volcanic islands are there in Iceland, and along this mid oceanic ridges we have thousands of volcanoes as circum Pacific belt. So, we have thousands of volcanoes. In Indian context, we have in Andaman Nicobar, we have this is volcanoes, the barren island. So, that means those volcanic rocks, especially the pyroclastics, they are mostly affected by this type of weathering as compared to others, and that create this type of shore platforms. The abundance and high perfection of shore platforms around the islands of this peripheral archipelago of this Pacific Ocean are part related to abundance of Cenozoic volcanic rocks in those regions. So, that means here we have number of volcanoes are there. So, at this periphery of these volcanoes, this type of weathering, these type of geomorphological features, they are mostly found. And these are this an example is given is this archipelago, this Pacific archipelago. Archipelago means there is a group of islands, this is called archipelago, they are genetically related, and if they are related to this hotspot, and here is the hotspot, and this is the oldest one, this side is the youngest one, and finally, we are getting along this periphery, this type of wave cloud platforms are there. Then another type of platform which is called solution platform, that so far we are discussing about this weathering of non-carbonate rocks or this wave action or the non-carbonate rocks. Here we will talk about the carbonate rocks. So, on carbonate rocks in shore zone, solution is so common that a special class of solution platform is distinguished. Solution platform, it may be very smooth or may be very rough, depending upon the degree of weathering and erosion. These are the most complex shore platform to describe, because their origin involves both chemical, biological solution and deposition. So, this platform, either there will be solution that is removal and there will be deposition by algal action. So, that means here we are getting undulating rolling topography type features. So, the removal is due to this chemical action and deposition mound formation is due to biological actions. So, that means solution platforms are generally intertidal. In this intertidal range, we are getting this type of solution platform, because when there will be high tide, there will be interaction of water around this rock, and there will be algal accumulation, and finally, there will be mound type of development landforms are developed there. Small pools alternate with low domes and ridges often formed by living carbonate secreting algae. So, this type of pools will be there, and this type of domes will be there, and this dome and pools are due to these carbonate rocks. their surface are flat and smooth, but not abraded. At the landward edge of the solution platform may be horizontal solution notches at deep edge 3 meters. So, here we are getting these solution notches. So, solution notches like wave cut notches, they are cutting into this landmass and finally makes the upper rock unstable, gravitational unstable, and that will promote this mass wasting. So, due to this biological action, due to this solution activity, then related to solution activity what are the notches are there and there will be mass wasting. So, complete package is there. So, there will be modification of this landform is due to chemical action as well as mass wasting. And here some of this photograph, if you see, this is chemical notches due to this reaction with the water, this type of notches are formed, and finally, these are these notches and these upper rocks becomes unstable and finally, they fall down into the system, and then this slope degradation or slope retreat occurs, and finally, the hill slope evolution whatever we are talking about this during our mass wasting class, this procedures again follows due to this wave action. Biochemical weathering and erosion play an important role in developing solution platforms and notches and abrade or dissolve this perforated rock surface to obtain the algae. Many intertidal plants, especially algae, penetrate their substrate with microscopic strands of organic tissues, that is lithophagic, that is called rock destroying animals, graze in limestone surface to obtain this algae. So, now we have algal erosion or algal mat, the development of mounds, and this some of these animals are there, they graze for their food, and finally, there will be physical weathering. So, the net chemical and mechanical effect is rapid and it is called bioerosion as much as 1 millimeter per year. So, irrespective of their nature, bioerosion, that means activities of biological activity, algal activities and those animals and all those biological systems, they contribute together, that is called bioactivity, and the bioactivity plays an important role for reducing this coastal landform and developing a coastal landform and especially to modifying the coastal landforms. Some of these salient features are here. Boring sponges has been reported to erode 23 kg per meter square per year from this reef limestone. Biochemical solution of 6.5 kg per meter square per year was measured on reef limestone at Hawaii. A limestone surface would be lowered a rate of 2.5 to 8.5 millimeter per year by such type of bioerosional process. Comparable subtidal bioerosion rates 2 to 10 millimeter per year have been estimated for this calcareous mudstone in California. So, that means I want to say this biological erosion, this bioerosion for these carbonate rocks and this non-carbonate rocks, these wave actions, this mass wastings, this tidal action, they totally they are acting together to shape the landscapes along these coastal landforms. So, I think we will stop here and we will meet in the next class. Thank you very much.